Uh, Hello all. Today I'm going to present you my final project, and it is based on the mechanical engineering component, and it's called like finding the stress energy of different load conditions of a suspended beam. It may be beam may be made up of like steel, aluminum, wood, or even concrete of the suspended beam, and we need to find a strain energy using Castigliano's theorem. And the load can be on a point load, or it can be based on an axial load, or it can be on a bending momentum or torsion. So each and every situation, we need to find integrated. We need to find the partial derivative of it, and based on the value we need to plot the graph. So let's get started. So this is the main objective of the Castigliano's theorem. So we need to calculate the strain energy of an elastic body. So the one which is brittle we cannot calculate because it already breaks and deform it. So these are the basic formulas which involve the Castigliano's theorem. So followed by, let's go to the code. So this is the code which I typed, the VS code, and we try to execute this entire thing in Ubuntu platform. So the first thing is that it starts to ask the strain energy calculator. First, it asks whether you need to have Young's modulus, whether you want to have the Young's modulus value or not. So in this case, I'm giving no. So in this case, it will provide some options, whether you want steel, aluminum, concrete, or wood. I'm gonna choose steel. And in steel, it's gonna show like axial load, bending load, torsion, or shear. So for steel, it's gonna be like 120 gigapascal. So the value is already been determined. The elastic modulus is already been determined by here. Axial torsion, bending shear. So in this case, I'm gonna show axial. So we need to enter the external. We need to enter the axial force in newtons. So uh, the force gonna be like 1,000 Newton, and we need to find the length and number of like meters. So the length is going to be 10 meter. This is the length of the beam, and the cross section area. The cross section area is going to be like a 4 mm square. Okay. Now this is the strain energy in the axial load, and it's showing in joules. So now based on this, we need to plot a graph. So we need to find the maximum bending moment. So I'm gonna give 5,000. So in this case, now it's not actually it's not able to plot the graph here. So I'm showing you how the graph has been plotted in the other platform. So if I want to do the calculation again, I have to press yes or no. In this case, I'm gonna pause the end the calculation. So I'm gonna give n, and that's it. So for the calculation part, I have done it over here. Um, it's gonna be the entire code over here. So this is the code, and this is the output which I got for the bending moment. And the reason it is showing 0, 0, 0, 0 is that the value is so finite. Sometimes it's not able to allow to show the entire value in this platform, but the actual value is stored. So when we are plotting it in a graph, it's actually able to replicate the value. So in the other case is that for the axial load, after I'm giving the 5,000, it's able to plot the graph like a linear graph, a linear curve graph. So if I compare the axial graph over here, so this is the axial graph of stored and released stored energy. So the energy is stored, and it's going to be a constant value. So this is how I'm able to obtain the answer with the applying the Castigliano's theorem, and able to incorporate it in Python, and able to put the output in Ubuntu. So I hope this was helpful, and I hope you have a better day.